This is a lesson for Wednesday, 9/23. We are taking a look at the notes for solving by square roots and imaginary numbers. This is going to be very similar to everything that we've been doing thus far. This is not drastically different, but we're going to take a look at how to solve different types of equations, slightly different types of equations. Up till now, we've seen things that if you can solve it by factoring, so hey, yeah, factors of 32, x plus 8, x minus 4, and get x equals negative 8 and 4. And those are also your x-intercepts, as we keep saying. Yes, we can solve it by factoring. What if it's something that doesn't factor? What if that 32 was maybe something like a 31? That's certainly not going to factor, as 31's prime, for one reason. What do? Okay, well, we have the quadratic formula we've been working on the last couple of days to solve that. But there are other types, and there are ones specific that have no x term. So solving methods, the order of solving methods is, first thing you want to look for is if there is only an x squared term and no x term, like this. And especially if they're not perfect squares, so it's not really that conjugate rule from factoring last week. So if you have a situation where there's no x term, which means there's no b, it would just be ax squared plus c. Then you're going to solve it by using square roots, kind of like what we did at the beginning of the year, where we're just using reverse order of operations. Okay? But if it's not that, then you look to see if it factors and use the ZPP. And if it can't factor, if neither one of those work, then lastly you would use the quadratic formula. So that's kind of the order that you want to approach this with. So solving by square roots is what we're going to focus on today. So we're going to do kind of the same stuff we were doing yesterday, only with these specific types of equations. And so we have a ball being dropped off a roof. It's not being shot up into the air. It's just I'm holding it, I'm on a roof, boop, drop it. This is the equation for the path of that ball. When will the ball hit the ground? So first of all, when the ball hits the ground is an x-intercept. We've talked about that before. When it hits here, this x-intercept represents something coming down and hitting it because the height is 0. So think about what h is. H is height. If the height's 0, that's where it's hitting the ground. So I'm going to set this equation equal to 0. 50 minus 16t squared equals 0. And I'm going to solve this. Again, there's no middle term. There's just two terms there. So I'm going to solve this by square roots. How would I solve for t? I would minus 50. And then divide by negative 16 on both sides. Two negatives make a positive. And then, and I'm going to do this work over here, I take 50 over 16, I have minus 50 divided by negative 16, and I take the square root. So t equals, and I have the square root of 50 over 16. But notice in my answer here, and we didn't do this earlier this year because we weren't ready to discuss this yet, but I have to have a plus and a minus. You must have a plus and a minus anytime you take a square root. Why is that? Well, think about what these quadratics are doing. It's going to have, if you draw a parabola, it's going to hit the axis twice. So just having the positive side doesn't work. You also need to have the negative side. So I have to do both plus and minus. Another quick explanation of that, especially for those that you're a little bit more mathematically inclined. You're going to need to know this for the future to continue on in math. Think about what the square root of 16 is. Square root of 16 means some number times itself, or squared, equals 16. So the square root of 16, it says, work backwards and figure out what this missing number is. Okay, 4 squared is 16. So the answer to the square root of 16 is 4. But wouldn't I also get 16 if I took negative 4 times itself? Negative 4 times negative 4, negative 4 squared would also give me 16. So it could be positive or negative 4. So when you're solving for an unknown value, you have to have both plus and minus. Now I am going to clean this up a little bit. I have the plus or minus, the square root of 50. Well, that would break down into 5 square roots of 2. We learned that in geometry. And that's just square root of 50 becomes the square root of 25 times 2. I break 50 up into 25 times 2. The square root of 25 is 5 square root of 2. If you don't know how to do that yet, we're going to deal a lot more with that in second semester. Don't worry too much about it. But I can take the square root of 16 for sure. And so I get this answer. So I get two answers, negative 5 squared root of 2 over 4 and positive 5 squared root of 2 over 4. Those are my x-intercepts. I'm going to get the approximate decimals for those. Just type them into the calculator and get the approximate decimal, plus or minus 1.7. So my x-intercepts are at 1.7 and negative 1.7. That's how long it takes to hit the ground, about 1.7 seconds. Just like yesterday, we're going to do the y-intercept, and this one's pretty easy. I have 50 minus t squared. I forgot my squared here. But anything times 0 is 0. So it's really, once again, just the constant. It's just that 50. So 50 feet high is where I'm dropping it from. And then I come to the vertex. Same thing as yesterday. Vertex is negative b over 2a. But it's even easier today because b is 0. Remember, this is my equation. Now, I didn't have it in this order at the beginning, but if I put it in standard form, that's my equation. There is no b term in here. So b is 0, and 0 divided by anything is 0. So the vertex is the same. Look up here at the y-intercept. The vertex and y-intercept. In these types of problems, but only these types, the vertex and y-intercept are going to be the exact same thing. So really, once you've found the y-intercept, you also have the vertex. You don't even really need to show any work or solve. Okay, really makes these nice and easy. And then we're going to graph these. You're going to graph them on paper. Here's my vertex and y-intercept. Here's my two x-intercepts. It might be good to get another point here, and then you can see that. So here's the path of the ball. They drop it from 50 feet. It's falling, falling, falling. 1.76 seconds later, it is hitting the ground. Okay? Oops, I moved the wrong thing. All right, so let's continue on. Now this second example is really the exact same thing, only there's a new twist that's being thrown in here, okay? And I'm going to focus on the twist here. No context, I'm just given an equation. We're going to find the key points and graph it. So x-intercepts, we set the equation equal to 0, same thing as yesterday. But then something curious happens. When I solve this 9x squared, and I'm going to do it over here live, 9x squared plus 70 equals 0, and I minus 70. And I divide by 9, and then I take the square root. What happens is I end up taking the square root of negative 70. Square root of 9 is 3. That's okay. And you can see I have that right here. Square root of 9 becomes 3. But I have the square root of negative 70. There's a problem here, because you can't take the square root of a negative. For instance, if I had negative 25 in a square root, you tell me what number times itself, or squared, would give you negative 25. 5 squared makes positive 25. Negative 5 squared would also make positive. I cannot get negative 25. So in our number system, there is no way to account for a square root that has a negative inside. A negative inside of square root just doesn't work. Now, that doesn't mean it doesn't exist in real life. It does exist in real life. Just our number system can account for it. So here's your rule. If you have a negative in a square root, it is called imaginary. It exists in real life, but in our number system, it's imaginary. So we use a lowercase I. So what do you do if you have a negative? You pop your I out. Yeah, play on words, pop your I out. So that means instead of writing it as the square root of negative 70, I write it as plus or minus I square root of 70. So the square root of negative 70, I pop my I out, and it's I square root of 70. Because I simply represents the square root of negative 1, or the square root of a negative. So we represent that negative that's giving us an issue with the letter I. By the way, just because it's imaginary doesn't mean it doesn't exist. These types of numbers are everywhere, including the technology that makes your smartphones possible, so don't diss the I. It's important in life. It's just you've never come across something like this before. I don't even know if I'm going to finish the rest of this really in detail. This is the same as example 1. X-intercepts, if it's imaginary, there are no x-intercepts. It never crosses the x-axis. Take a look at my graph here. You can see this graph will never hit the x-axis. That's why they came out as imaginary, because they don't exist. There are no x-intercepts. The y-intercept and the vertex are 0, 70. So how do I get some more points? Well, we just use the table app or the trace feature like we did last week, just to get a few more points to fill in the gaps, and then draw your function using whatever scale you think is appropriate on the y-axis. Okay? You can stop the video, go work on the homework, pop back in if you want me to go over more with imaginary numbers. I'll do some of the homework problems with you into the live session if you want. But go ahead and get that done now.